Hello and welcome to DTW Tutorials. Welcome. So today's question, we have a JAMB physics question here. It says a battery of EMF 12 volts and internal resistance 1 ohm is connected to an external resistor of 3 ohms. Find the power delivered by the battery. Okay, I hope you remember what EMF is. All right, and let me quickly just explain what EMF is. Now, EMF has like two definitions. All right. EMF all concerns the cell. A battery is a cell that delivers current. All right. So for this question here, this is a closed circuit, okay, because it delivers current to an external um, circuit, which is the resistor here. Okay. So for EMF, an EMF is, okay, the potential difference between the terminals of the cell when it is not delivering current. Okay, when it's not delivering current, meaning that this circuit is open, but when it is delivering current, we have something like this. All right, where from our question, this is the battery, the EMF is 12 volts, all right, and the internal resistance is 1 ohms, and it is delivering current, okay, to an external resistor of what, 3 ohms. Okay, so this is a closed circuit. So in this case now, what is the EMF, the electromotive force in this case, when it is now delivering current, that's electricity. So it is the work done, okay, in moving a unit charge through this what circuit. So it's a total PDF. Okay, that's the I say PDF, sorry, it's not PDF. Potential difference is a total PD. Okay, in the sum of the total PD, that's that's total PD here, total PD here, in each component, the sum, that will be the EMF of a closed circuit. But for an open circuit, it's just the PD, that potential difference between the cell terminal. All right, so that's EMF. Now, coming to our question, it now says we should find the power delivered by the battery. All right, so we know the volts of the battery, we know the internal resistance, we know the external resistor here, the resistance that we have here. So what do? We have to first find our current. We need to know the current, okay, that this battery can supply. All right, so remember our formula. E, okay, total EMF is equal to what? I in parenthesis R plus R. All right, where R is this the external resistance, and this R here is the internal what? Resistance. Okay, so we're looking for I, so that will be, we just divide this, so I will be what? E over R plus R. So what is E? E is 12 volts. That's the volts of the uh, uh, battery. So that's 12 over R, external resistance is what? 3, plus internal, which is 1. So we have 12 over 4, and 12 divided by 4 will give us 3. So our current, okay, is what? 3 ampere. Now, that we're not stopping there, because we're looking for the power delivered. Remember our formula for power. Okay, power is either PIV or P equal to V square over R, or P is what? I square R. I think the best formula to use here is I square R. We have our current, okay? That's the formula we use. All right, so we have our current. So we need to know it says find the power delivered by the battery. So the power delivered by the battery is the one it delivers to the cell itself, because the cell has an internal resistance, and also the power it delivers what? To the external resistor. All right, so it will be this, it will be I square small r plus I square big R. All right, so I square small r, what's the I? Our I is 3. That's 9 times, that's 3 square. Remember, 3 square times. All right, for the first one, R is 1. So 9 times 1 will give us what? 9. And for this, I square R, that will be 9 times 3. And what's 9 times 3? That's 27. So we have 27 plus 9. And what's 27 plus 9? That's going to give us what? 36. Okay, so be careful. You can see I know most people will just say, oh, power delivered by battery. They'll just look for, you just look for the current and then just calculate only this, forgetting that it also delivers power also to the cell. Are you seeing me? Because as I said, current is delivered to the cell, its cell, that's the source, and also to the external what circuit, okay, which is this resistor here. All right, so you have to add them up. All right, so this will be the total power delivered by the battery, which is what 36 watts. And our right option here is option A. All right, thank you for staying tuned to the end of this video. Please don't forget to get the DTW JAMB CBT app. Okay, you can download from Google Play Store. It contains all your past questions from 1992 and till date with their correct solutions. You have your class notes there. You have your literature text, the life changer, your all your literature books, the summary, questions on it, everything is on the app. Wonderful app to use to prepare for your examination. Okay, because right now it is time to study and practice. Not yeah, it's just time to practice, 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 practice. All right, okay, and you can also join our intensive JAMB online tutorials. All right, thank you. You are destined to win. And don't forget that Jesus Christ is coming soon. Please do give your life to Christ, for He is the way, the truth, and the life. You are blessed. See you in our next video.